Okay, hello everyone. What I'd like to do today is go over some homework questions, but also go over some of the questions from the chapter that the homework came from that I didn't assign. I was looking back through the chapter and just thought that maybe we should look at a few of these, not necessarily do them all, but go over them maybe orally and see if there are any questions about how to do them. A lot of them are very easy. Some of them look scarier than they are. But these all are questions that lead up to the rational unit that we're about to start, that we've kind of already started. So, a lot of the stuff we've already done because it's appeared in other units here and there. But I felt like some of them were worth going over. So that's what we're going to do today. We will tackle the questions from the homework as well, but let's just look at a whole bunch of things. And as I was telling the previous class, sometimes looking at the homework questions that aren't assigned is a good idea, because oftentimes you have to ask yourself, why did the teacher not assign those? Is it because the teacher expects us to already know them and be comfortable with that material? Is it because the teacher is planning on using those questions in a test and doesn't want to give them as an assignment before they're on the test? So it's not a bad idea to peruse some of the questions around the questions that are assigned for homework, just to be sure that nothing is a surprise if it ever pops up later on. All right, so let's get it started. You'll notice with question 1 here, I would actually assume that everybody would be able to do those. We've seen scenarios where we're adding algebra terms together already. Grouping like terms is the technique that we use. Yes, they might look a little bit scarier because there's multiple variables and there's multiple terms, but this is not, in my opinion, anything that should be causing you too much difficulty. It's just an addition of like terms. For question 2, however, this one always scares me a little bit when I assign those to students, because there's one common mistake that's done almost all the time. So let's just take a look at one of these together. Let's do 2b. So we've got, okay, I better use a different setup for my s's here so that they don't look like 5s. So 5s squared plus 8s minus 12 minus 6s squared minus s plus 4. So I'm using a cursive s just so they don't look like 5s. The biggest mistake that I see is with what that minus sign does in front of that bracket. And we may have discussed this before, but I just want to repeat it again. That minus sign is a -1 that's distributing through that bracket. And that means that every term in that bracket is affected by that -1. All of the signs change. And I can't tell you how often students will make this mistake right here, and they'll only change the first term in the bracket and not the 2 other terms. And I mean, frankly, I may have made that mistake in the past too. It's really easy to forget that that is a distributivity scenario. So I like to think of it as the entire bracket is subtracting from the entire first bracket, and that means every term inside of that bracket is subtracting from the original bracket. Okay? And then it's just a matter of collecting like terms, which I'm not going to do. I'll point out which ones are like terms here. Okay? But that should be pretty easy to do from that point on. And if you look at all of the questions in number 2, that's the only thing you're practicing, is being able to distribute that negative sign into that second bracket properly. Okay? So that's pretty much all I'm going to talk about for that question. For questions 3, 4, 5, and 6, these questions are all questions as to, do you understand the language of mathematics? What is a sum? A sum is an addition. Okay, now they helped you out here by using the word add as well. Oh. Okay, the word add right here is in there. That means addition, obviously. Okay, but they could have just said find the sum of those two, of those 3 expressions. Okay, so add the sum of this to that. Now the one that is most concerning to me is this one right here and this one right here. These two are the ones that are the ones I'd like to focus on. Subtract 3t squared plus 4t minus 7 from the sum of those two things. Okay? That means you have to set that up properly. It has to be the sum of the two things first. You don't technically need the brackets. Okay? Subtract from the sum means the subtraction would be the last thing to occur, and that subtraction absolutely has to be in a bracket. Okay? And the rest should be easy if you understand 1 and 2. So it's just the language and being certain that you understand the language. For question 6, subtract the sum of those two things from that one. Okay, and this one I'm going to do down here. So subtract the sum of from. So that means the 3m squared plus 4m minus 1 is first. And we're subtracting the sum of those two other things, which means those have to be in a big bracket. Now, these interior brackets aren't necessary because it's just an addition of two expressions. Okay? Let's just call it A and B. How's that? But this is important. Making sure that you have a subtraction with a bracket there to follow the language of the question is very important. Question 7. The perimeter of a triangle is given by this expression. If two sides have lengths 3y plus z and 4x minus y plus z, what is the length of the third side? So this is basically the exact same question as 6. You want to add the two sides together and subtract it from the perimeter to find the value of the third side. Okay, so it's one of those questions that I was talking about the other day where you've got some algebra hidden inside of another type of question, which normally wouldn't happen, but they're just trying to spice things up and ask it in a slightly different way. Okay, so all in all, I feel like these questions you should be able to do with very little difficulty. So that is my expectation. For these questions, 8 to 10, this is just distributivity along with the addition and subtraction of terms. Okay, so I'd like you to just take a look at those questions a little bit and ask yourself, would you be able to simplify and expand and simplify those expressions? When you look at question 10, are you okay with those big square brackets and the round brackets? Would you be able to deal with that? So it is my expectation that you should be able to do those. And if you feel like you can't, you may need to start practicing with some of the easier ones up here. Look in the back of the book, check to see if your answers are correct, and try to work your way through until you can get to the more difficult ones down here. And if you have any questions, you can email me. But I don't feel like we need to spend too much time on this stuff. It is, by the way, warm-up questions to the rational section that we're going to be working on. A lot of this stuff is going to come back in that rational section. So, I mean, at that point, if you're struggling with it, you can always ask for help too. But it's always better to be pre-prepared, right? Is that a redundant? Anyway, whatever. So I'm not going to do any of these because I feel like most of you should be able to do them without too much problem. So let's look at the next ones. If you look at these, what are they asking you to be able to do? Well, if you look up here, what is the main topic of all of those questions? It's just FOIL. Can you multiply a binom times a binom, which we've been doing since we were doing quadratics at the beginning of the semester. Okay? And these are the exact same things. They might be a little bit different. Like if you look at D, there's a coefficient in front of the two brackets, but we've seen scenarios like that. We've even seen scenarios where there's two different letters involved. We were factoring those. So again, I feel like those should be pretty easy. And I mean, even looking at the last question in 13, which might be one that looks more imposing, it's just a bunch of combinations of FOIL, right? So it's longer, but it isn't more difficult than any of the other questions. So, you know, again, just trying to get you to think about these things. Are you comfortable with this stuff? It will pop up later on. But do we need to actually practice them? Can you go through that and say, yeah, I'm able to do those? And I'm kind of expecting you to be able to do that. Okay, moving on. So this is where the homework questions started. I actually don't remember which ones I exactly asked you to do. So feel free to ask me to do any of the ones from homework. I know somebody asked me to do O in the last class, so I can definitely do O again. It is the last one, which is usually the most difficult one, right? But other than O, chat, can you tell me, and I'll give you a few seconds to answer, are there any of those questions that you would like me to do right now? N? Sure. Okay, so let's start with N. I don't see any other suggestions right now, but if you have any more, you can definitely let me know. So what I'm going to do for N, if you don't mind, I'm going to do it in three separate steps. Okay, I'm going to deal with just the multiplication of x minus y plus z times x minus 2y minus 3z. And then separately, I'm going to do the x plus y plus z squared. And then we'll bring it all together into the final answer, okay? So now my preference for doing this multiplication would be to set it up, the way that I showed yesterday with my little grid. It's a 3 by 3. And I'm just going to multiply x times x, which gives me x squared. Now, please watch me carefully here. Did I miss a 4? Yeah, I'm going to do the 4 after. I'll bring the 4 in at the end because that's not part of the real difficult. Yeah, okay, cool. But please watch me because I did make a few little mistakes. Okay, it's easy to get carried away with how fast I want to go through this, so just watch me very closely. So x times x is x squared. X times negative 2y is negative 2xy. X times negative 3x is negative 3x squared. Negative y times x is negative xy. Negative y times negative 2y is positive 2y squared. Negative y times negative 3x is negative 3xy. Z times x is xz. That'll be negative 2yz. And then negative 3xz. Now, my diagonal thing isn't going to work out in some of these, as you can see. It's not going to be diagonals that are like terms necessarily because of the amount of terms there are and the amount of letters there are. So let's see, it does work for this one here. So we've got x squared minus 2 minus 1 is minus 3xy. So I've done those two. Now I've done, okay, so this x squared is actually going to join with this 3x squared, which I just noticed. So, or minus 3x squared. So it's going to be minus 2x squared. So I've done those two. Now I've got an xy here that's going to join, oh, I forgot that xy. So that xy is going to join with those two xy's. So I'm going to have minus 6xy with that one. And then I have an xz and an xz. So it's xz minus 3xz, which would be minus 2xz. So these two are gone. And then I've got a minus 2yz and a plus 2y squared. Whew. So if I didn't make any mistakes, I think I did that okay. All right. So just for kicks, I'm going to do the x plus y plus z the other way. Now that's x plus y plus z squared. So that means there's two of them. And I'm going to need a little bit more room. So I'm going to do multiple distributivities here. Actually, let me use different colors to show. Okay, so I'm going to do multiple distributivity instead of setting up my grid, just to show you the difference between the two. So, and I'm probably going to need more room, so I'm actually going to do this on the next line here. And let me separate those so that they don't look like they're the same equation. Is that stating that I made a mistake in the previous one? Did I miss a z squared? Oh, to this one, to this next one. Okay, I see. Thank you. Okay. So x is going to be x squared plus xy plus xz. And then in green, we're going to have plus xy plus y squared plus yz. And then in purple, we're going to have plus xz plus yz plus z squared. Okay, and this is what I was talking about yesterday when I said that I kind of prefer this grid, just because of how many of these terms there are, and finding the like terms. Now, it kind of didn't work for me anyway with my grid because the like terms didn't line up because of the letters, and that sometimes happens. But what are my like terms? Are there any other x squared terms? No. Are there any xy terms? Yes. Are there any xz terms? Yes. Are there any y squared terms? No. Are there any yz terms? Yes. So you just have to search through and find them. Okay? I don't know. Maybe it's not that big a deal. But so x squared plus y squared plus z squared. Now this allows us to talk about what the formatting is for how you should write these kinds of things. They usually are written in descending powers still. So anything that's a squared will be written first. And then they should also be written in alphabetical order. All right. Now I'm not going to worry too much about that because is an xy before an xz? I don't know. Probably. Okay. But does it really matter in the long term? So we've got xy plus xy, which is plus 2xy. Xz plus xz, which is plus 2xz, and then yz plus yz, which is plus 2yz. Okay, and because this is a trinome squared, there's probably some sort of pattern we could have used to do this quicker, but I just wanted to show you how the distributivity aspect of a trinome times a trinome would work if you did it all in one line or two lines like this. Okay? All right, we're not done. Now we've got to combine them all together. So we've got 4 times the first one. So this is the first one right here. So I'm just going to multiply all of that by 4 and write them all out. Okay. So my answer is going to be minus 8x squared minus 24xy minus 8xz minus 8yz plus 8y squared. And that's multiplied by 4 because of the 4 that's in front of those two brackets. Then we have minus the next one. The next one is here. So I'm subtracting all of those. So it's going to be minus x squared. Now I'm going to put the minus y squared over here underneath the 8y squared, just to keep them all kind of grouped up. I'll try to do that for all of them. We've got a plus z squared, which becomes a minus z squared because it's subtracted. That doesn't have anything to join up with in the first one. We've got a plus 2xy, which becomes a minus 2xy when I'm subtracting. A plus 2xz, which becomes a minus 2xz when I'm subtracting. And plus 2yz, which becomes a minus 2yz when I'm subtracting. And then I've got to subtract x squared minus y minus 2z. Well, because I'm subtracting those three, all three signs are going to change. So it's going to become a minus x, a minus y, and plus y, and a plus 2z. And now I can collect all my like terms. Okay? Well, you'll notice that these three I just placed here because I didn't have any other room. But they actually don't have any like terms. Okay? So those three terms are going to be all by themselves. But we're going to have, so these two group up, minus 9x squared. And then these two group up, which will be minus 26xy. And then these two group up, which will be minus 10xz. And then these two group up, which will also be minus 10yz. And then these two group up, which will be plus 7y squared, minus z squared, and then minus x plus y plus 2z. And I don't know if I made any mistakes there. Whoops, I wrote zz there, sorry. I am not going to double check. Okay, so that was definitely a very long question to do. And you can see how very careful you have to be to not make any mistakes. But there you go. Okay. Just a quick question. How many people in chat know about the Wolfram Alpha website? I'm going to write that down in chat so you see what I just said. Okay, it's the Wolfram Alpha website. If you don't know what that website is, look it up. And maybe I'll do a quick little tutorial on some of the benefits of that website to you, because it is an amazing mathematical tool. Unfortunately, they recently made it so that it's not quite as amazing because you have to pay for the amazement of everything that's on there. But it still works quite well for certain things. And for an example like this, I potentially would have gone to Wolfram Alpha to check my answer. So are you talking about the lesson right now that there's lag? So I wrote it in chat. I'm not going to show the website today. I'm asking you to go see it, but I'll definitely show it to you someday. Okay. All right. Let's move on. So I'm trying to make sure I'm doing the similar thing that I did in period 3 here. I'm going to skip O. I know I had circled O, but because we did the previous one to O. Oh, you're having trouble hearing. Is anybody else having trouble hearing my my stream right now? Okay, there's nothing I can do. It says excellent on my end here. Maybe it's at your end that you're having the lag. Okay. Well, if you have to, you can always watch it later on YouTube or from the video. Sorry about that. I'm a little quiet. My volume a little bit low. I'll try turning it up a little bit. Is that better? Okay, so let's take a look at 16 to 19 here quickly. I want you to take a look at 16. It says multiply x plus 1, x plus 2, then multiply the result of by x minus 3 and simplify. And then in B, it says multiply x plus 1, x minus 3, then multiply the result by x plus 2. Now, what are they asking here? And if you get to D, it says, does the order in which you multiply 3 binomials affect the result? So this is just asking you to check the commutative rule in multiplication. Okay, if you multiply the three of them in any order, you should get the same answer. Question 17, basically the same idea. I'm not going to do it, but there's a 4-term squared scenario. So that would be distributivity with 4 terms, which would give you 16 terms, right? We just did a pretty big one, so I'm not going to do this one as well, but it is expected that you would be able to do it. It might take a little bit of time, but it's expected you would be able to do it. Question 18. Do you remember from grade 9 the volume formula and the surface area formula for a rectangular based prism? Volume is pretty easy. It's just length times width times height. Now, just a quick reminder, for the surface area of a rectangular based prism, I'll call this length, I'll call this width, and I'll call this height. The way I think of this is you've got 2 of this shape, the front and back, 2 of this shape, the right and left, and 2 of this shape, the top and bottom. Okay, so for the surface area of a rectangular based prism, it would be equal to 2 times top and bottom, which I wrote in purple, which would be length times width, plus 2 times front and back, which would be height times width. I forgot the 2. And then plus 2 times red, which is right and left, which would be length times height, which you might have seen with the 2 factored out, okay? But what I want you to notice is the formula wasn't given to you in that question. That's because they're expecting you to know it, both the volume and the surface area formula. And if you don't remember it, they're expecting you to be able to at least do it like I just did, create it from the picture. Okay, so those are the kinds of things, like, I mean, and it's easy to forget that kind of stuff if you don't use it very often. So now I would probably be able to be convinced to give it to you, okay? But that is the expectation there. They're kind of expecting you to just know those formulas. All right. Question 19, write and simplify an expression to represent the shaded area only of this shape. Well, they gave you the length and width of the outside. They gave you the length and width of the inside. Multiply the length and width for the whole thing, and then subtract the length and width for the inside. Multiplied together, right? And that's just a combination of, you know, some of the questions we've just seen mixed into like a shape question to make it a little bit more spicy. Okay? So I hope you're getting something out of this, folks. Like I said, I think it's worthwhile doing just to see the style of questions that you could potentially be asked, even though I didn't technically teach them. I'm expecting you to be able to do some of those. These 2 questions are very interesting. Is the product of 2 binomials always a trinomial? Chat, can you think of an example? and what kind of example it is where that is not going to happen, where two binomials multiplied together won't be a trinomial. And we've already done this, right? Somebody in chat just gave us an example. How does a difference of squares work? Right? These are two binomials multiplying. The word product, by the way, means multiplication, so they're expecting you to know that too. This would give x squared plus 3x minus 3x is 0, minus 9. That is a binom from two binomes multiplying each other. Something that they're expecting you to know, right? For question 21a, how would you multiply those two? What is the easiest way to proceed? And look at what we just saw in question 20. That is also a difference of squares. So now we're going to talk about this one a little bit more in detail. If I square the first term, subtracted by the square of the second term, I get this. Now, the question becomes, how simple is simplified? Is this written in the most simplified version that it could be written in? Now, I don't actually know the answer to this question. I would say yes as well. But what if I asked you to combine those two terms? If I asked you to combine those two terms, and the reason I'm doing this is because we're going to be starting, we've already started the rational unit, but we're going to be doing a lot more of this, where we're combining fractions that have an x at the bottom with other things that have x's in them too. How do you go about doing that? Well, you need a common denominator. You can't subtract fractions unless you have a common denominator. So I'm going to multiply the top and the bottom here by x squared. That's going to give us x to the power 4 minus 1 all over x squared. But what's that? That's another difference of squares. So I could write that as x squared plus 1, x squared minus 1, all over x squared. But what's that? Now you might be asking yourself, why am I doing this? So the first thing I want to point out is this simpler than that? And I think there'd be a debate that we could have about that, right? If you have two terms adding or subtracting, is that simpler than having one term where you have a numerator and a denominator? I'm not sure about the answer to that question. Okay, I can tell you my preference. My preference would be this version. Okay, I find that looks nicer than this one. But I'd have to accept both because both are the same answer. Okay. Now, why would we want to go this far? Because in the future, very near future, we're going to be doing scenarios where you have to factor everything to the last factor possible. Okay? Because things are going to start to cancel out. So noticing that there's another square difference of squares in both of these final, quote unquote, final answers could become important later on. All right? So again, just, let's just talk about the math a little bit, like what's going on here. So the first thing I'd want to make sure you understand is why we need a common denominator to be able to combine those two together, okay? And if you look at B, which I'm not going to do, it would be a great one to do in practice if you wanted to. In B, it's not a difference of squares. So what would be the best way to proceed for B? Is foiling okay? Is there a better option than foiling to start? Okay, what would be the best way to do B? And I'm not going to answer the question. I'd like you to think about it. Maybe try it yourselves. Okay. And finally, we are at the last question from the homework. So we've got, I can't remember exactly which ones I had given. I think it was A, C, E, and F, if I'm not mistaken. Oops. I think those were the ones that I had assigned. Okay. So these are pure, simplify and find the restriction questions. All right. So if we look at question A as a bit of a warm-up to yesterday's lesson, there is a word that I was trying to drill into your heads yesterday about what is the proper way to simplify these. And the word is factoring. You have to factor before you simplify a rational expression. Now, before we even do that, we have to set our restrictions. Because if you start to factor before you set your restrictions, you might actually eliminate some of your restrictions, which is not okay. You have to state your restrictions first. So I think somebody in chat's already mentioned what is the value that t can't equal, and t can't equal 0. So that is our restriction. Then we factor the top because we can. So what can we pull out of everything? Well, we can pull a 3t out of everything. We're left with, we're left with t squared plus 2t minus, whoa, my brain just had a hiccup there, 5 divided by 3t. And now, because the main operation is a multiplication, we can cancel out the 3, we can cancel out the t. And only then are you allowed to do that. So our final answer is a parabola, but that parabola has that restriction, which means it's going to have a hole on it somewhere at t equals 0. C is the exact same thing as A. I'm not going to do C. If we look at E, which I had not shown you an example of, what happens if you have multiple letters in the denominator? Well, you treat them individually. Forget about the n for a second. What value can m not be equal that would potentially make the denominator equal to 0? Well, m can't be equal to 0. Now, forget about the m. N is also multiplying and also can't be equal to 0. Right? So you would just state both letters and whatever their restrictions are separately. And then you factor. So we can pull a 4m out of both of those. And now that everything is multiplying and dividing, the 4's cancel out, the m's cancel out, and you'd be left with your final answer of m minus 2n over n. Sorry, my equal sign should be around the division symbol there. Okay, so that is your final answer with those restrictions. If we look at number 2, I'm going to skip f because it's basically the same thing. Okay, sorry, I should probably go and talk about f a little bit here. F has an x cubed in the denominator, but that doesn't matter. It's still x can't be equal to 0. Okay, because x cubed can't be equal to 0, so x can't be equal to 0. Y can't be equal to 0 either, and then you would just... now, would factoring be necessary here? Probably not. You could just use the exponent laws at that point. Okay. So I'm going to leave f as a bit of a challenge, and if you need more help with that one, let me know. For number 2, if we do 2a orally here, what value can x not equal? Well, because it's x plus 4, x can't equal negative 4. Then the 5's cancel out. So you're left with x over x plus 4. And all of them are very similar. If we look at D, and I'm going to finish with this one. Now, what I'd like you to do for this example, folks, is I'd like you to, in your brain, expand the top and the bottom. And I want you to see that you'd have a trinomial at the top and a trinomial at the bottom. That's where we're heading. We're heading to scenarios where that's the way the question starts. Then you'd have to factor it to get it into this form, because this is the only form that you can see your zeros properly. Not your zeros, sorry, your restrictions, my mistake. Okay? So your restrictions would be m can't be equal to 4, to negative 4, sorry, and m can't be equal to 1. And once you've done that, m minus 1 can be canceled because everything's multiplying and dividing, and our final answer is m plus 2 over m plus 4. And that's going to be it for today's lesson.